For example, colony starships. Colony starships represent one of the most ambitious and exciting concepts for the future of humanity in space. These enormous spacecraft would be designed to carry large populations on long-duration missions, with the goal of establishing human colonies on distant planets or even in other star systems. Unlike the shorter trips undertaken by current space missions, colony starships would need to sustain their inhabitants for years, decades, or even centuries as they travel through the vast expanses of space. The successful development and deployment of such starships could play a crucial role in humanity's long-term survival and expansion beyond Earth. A colony starship would work as a self-sustaining closed-loop environment, essentially functioning as a small artificial world. It would be equipped with advanced life support systems that recycle air, water, and waste to maintain a stable and habitable environment for its passengers. These systems would need to be highly efficient and reliable, given the isolated nature of the starship and the impossibility of resupplying from Earth during its journey. Food production would be handled on board through hydroponic or aeroponic farming systems, where crops are grown without soil, using nutrient-rich water or mist. This would ensure a steady supply of fresh food for the crew and passengers. One of the key challenges in designing a colony starship is providing artificial gravity to counteract the effects of long-term weightlessness on the human body. One solution is to build the starship in a rotating design, where centrifugal force would create gravity-like conditions on the inside of the rotating sections. This would allow the inhabitants to walk, live, and work in an environment similar to Earth's, preventing the muscle and bone loss that occurs in microgravity. This rotating section could be designed as a large ring or cylinder, with living quarters, workspaces, and recreational areas built into the inner surface. In addition to its physical infrastructure, a colony starship would need to address the social and psychological needs of its inhabitants. Living in a confined space for extended periods can be challenging, so the starship would be designed with diverse and adaptable habitats that simulate natural environments, such as parks, forests, or even simulated weather patterns. Entertainment, education, and social interaction would be facilitated through advanced virtual reality systems, allowing passengers to stay connected with each other and with life on Earth. Psychological support and community building would be critical to maintaining the mental well-being of the starship's population. The benefits of colony starships for humanity are profound. First and foremost, they offer a way to ensure the long-term survival of our species. Earth is vulnerable to various existential threats, including natural disasters, pandemics, and potentially even man-made dangers like nuclear war or climate change. By establishing colonies on other planets or in other star systems, humanity would reduce its dependence on a single planet, ensuring that our species could continue to thrive, even if Earth were to face a catastrophic event. Colony starships also hold the promise of expanding human civilization across the cosmos. By venturing beyond our solar system, we could discover new worlds with untapped resources, unique environments, and possibly even extraterrestrial life. This would open up new opportunities for scientific discovery, cultural exchange, and economic growth. As humanity spreads to new frontiers, we would carry with us the knowledge, culture, and diversity that make our civilization unique, creating new societies and ways of life in distant parts of the galaxy. In the future, colony starships could also serve as the foundation for a spacefaring economy. These starships could establish trade routes between Earth and newly colonized planets, exchanging goods, technology, and information across vast distances. The development of these starships would drive advancements in propulsion technology, material science, and space infrastructure, with benefits that could be applied to other areas of space exploration and industry. The ability to travel and trade between star systems could lead to a new era of economic growth and innovation, with humanity taking its place as a multi-planetary civilization. Make sure to stick around to the end because this video explores Dyson spheres, O'Neill cylinders, ring worlds, planetary shields, wormholes, and more. Number 2. Dyson swarms. A Dyson swarm is an ambitious concept that could revolutionize humanity's approach to energy generation by harnessing the immense power of the sun. Unlike the more well-known Dyson sphere, which envisions a solid shell surrounding a star, a Dyson swarm consists of a vast number of individual satellites or solar collectors that orbit the star in a coordinated pattern. These satellites would capture a significant portion of the star's energy output and convert it into usable power, potentially providing near-limitless energy for humanity's needs. The idea behind a Dyson swarm is to create a distributed network of solar collectors that can be gradually expanded over time. Each satellite in the swarm would be equipped with advanced solar panels that capture sunlight and convert it into electricity. This energy could then be transmitted back to Earth or other locations in the solar system using wireless energy transfer technologies such as microwave beams or lasers. The modular nature of a Dyson swarm allows for flexibility in its construction because additional satellites can be added incrementally, each contributing to the overall energy output. One of the primary benefits of a Dyson swarm is its potential to solve humanity's energy challenges. By capturing even a small fraction of the sun's energy, a Dyson swarm could generate more power than all of Earth's current energy sources combined. This abundant energy supply could support the growing global demand for electricity, enable the widespread adoption of renewable energy, and provide the power needed for advanced technologies like artificial intelligence, space travel, and large-scale computing. In addition to meeting Earth's energy needs, a Dyson swarm could also support future space exploration and colonization efforts. The energy harvested by the swarm could power spacecraft, habitats, and other infrastructure in space, making it easier to establish colonies on the Moon, Mars, and beyond. This energy could also be used to fuel advanced propulsion systems, enabling faster and more efficient travel between planets and potentially even to other star systems. The availability of abundant energy in space would be a key enabler for humanity's expansion into the cosmos. Another significant advantage of a Dyson swarm is its potential to mitigate the environmental impact of energy production on Earth. By relying on the sun's energy, humanity could reduce its dependence on fossil fuels and nuclear power, which have associated risks and environmental consequences. A Dyson swarm could help reduce greenhouse gas emissions, slow climate change, and decrease pollution, contributing to a more sustainable and environmentally friendly energy future. Building a Dyson swarm would also drive technological innovation and create new industries. The construction of such a massive and complex structure would require advancements in materials science, robotics, and space manufacturing. Automated systems and self-replicating machines could be developed to construct and maintain the swarm, reducing the need for human intervention and making the process more efficient. The technologies developed for a Dyson swarm could have applications beyond space, benefiting industries on Earth in areas such as energy, telecommunications, and manufacturing. Moreover, the concept of a Dyson swarm aligns with the long-term vision of humanity becoming a Type 2 civilization on the Kardashev scale, a society that can harness the energy output of an entire star. Achieving this level of technological and energy capability would represent a significant milestone in human progress, enabling us to address global challenges more effectively and pursue more ambitious goals, such as interstellar exploration and the search for extraterrestrial life. Number 3. O'Neill cylinders. O'Neill cylinders are a fascinating concept for space habitats that could one day provide a home for millions of people beyond Earth. Proposed by physicist Gerard K. O'Neill in the 1970s, these gigantic cylindrical structures would rotate in space to create artificial gravity on their inner surfaces, allowing people to live and work in a comfortable, Earth-like environment. O'Neill cylinders are envisioned as a solution to overpopulation, resource scarcity, and the challenges of sustaining large human populations in space, making them a key element in humanity's future as a spacefaring civilization. Jeff Bezos has also proposed this megastructure as a viable solution for the future. An O'Neill cylinder would work by using centrifugal force to simulate gravity. The cylinder, which could be as long as 20 miles and several miles in diameter, would rotate around its central axis. This rotation would push everything inside outward toward the inner surface of the cylinder, creating a gravity-like effect that would allow people to walk, live, and build as they would on Earth. The inner surface of the cylinder would be divided into different zones, with some areas dedicated to cities, others to agriculture, and still others to natural landscapes. Large windows made from transparent materials would allow sunlight to enter, providing natural light and enabling photosynthesis for plants. In addition to providing living space, O'Neill cylinders could be a hub for advanced industry and research. The microgravity environment outside the cylinder, combined with the controlled environment inside, would make it an ideal location for manufacturing high-tech materials, pharmaceuticals, and other products that are difficult to produce on Earth. Research facilities in O'Neill cylinders could also conduct experiments in fields like physics, biology, and material science that take advantage of the unique conditions in space. This could lead to new discoveries and innovations that benefit both the inhabitants of the cylinder and people on Earth. O'Neill cylinders could also play a crucial role in the colonization of the solar system. Positioned in orbit around Earth, the Moon, or other planets, these cylinders could serve as way stations for missions to Mars, the asteroid belt, and beyond. They could provide a base of operations for mining asteroids, extracting valuable resources such as metals and water, and processing them into useful materials. The resources gathered from space could then be used to build more O'Neill cylinders, further expanding humanity's presence in the solar system and creating a self-sustaining cycle of growth and development. Another key benefit of O'Neill cylinders is their potential to create a more sustainable and equitable society. The controlled environment of the cylinder would allow for the implementation of advanced agricultural techniques such as vertical farming and hydroponics, which could produce food more efficiently and with less environmental impact than traditional farming methods. The abundance of solar energy in space could be harnessed to power the cylinder, providing a clean and virtually limitless source of energy. These factors, combined with the vast living space available, could enable the creation of a society that is less dependent on finite resources and more focused on sustainability and long-term well-being. In the future, O'Neill cylinders could also become cultural and educational centers, preserving and promoting human knowledge, art, and traditions. As humanity spreads across the solar system, these cylinders could serve as repositories of culture and history, ensuring that our shared heritage is not lost as we explore new worlds. Educational institutions within the cylinders could provide training in the skills needed for life in space, preparing future generations for the challenges and opportunities of a spacefaring civilization. Number 4. Planetary shields. A planetary shield is a visionary concept that could play a crucial role in protecting Earth or other planets from a range of potential threats, both natural and artificial. This immense structure, or series of interconnected structures, would be designed to shield a planet from hazards such as asteroid impacts, solar radiation, space debris, and even hostile attacks. By acting as a protective barrier, a planetary shield could safeguard the inhabitants of a planet, ensuring the continuity of life and the stability of the environment. The concept of a planetary shield could be realized through several different technologies, depending on the specific threats it is designed to counter. For instance, to protect against asteroids and space debris, the shield could consist of a network of high-powered laser systems or electromagnetic railguns positioned in orbit around the planet. These systems would be capable of detecting incoming objects and either deflecting or destroying them before they could reach the surface. The lasers could vaporize smaller debris or alter the trajectory of larger asteroids, preventing catastrophic impacts that could cause widespread destruction. To shield against solar radiation, particularly harmful solar flares or coronal mass ejections, the planetary shield might incorporate large arrays of magnetic field generators placed in strategic locations around the planet. These generators would create a powerful artificial magnetic field, similar to Earth's natural magnetosphere, which could deflect charged particles from the sun. This would protect the planet's atmosphere from being stripped away and shield electronic systems from the damaging effects of intense solar radiation, thereby preventing disruptions to communication networks, power grids, and satellites. In the context of planetary defense against potential hostile attacks, the planetary shield could be equipped with advanced missile defense systems, particle beams, or even a form of energy barrier. These defense systems would be capable of intercepting and neutralizing any threats before they could cause harm. The presence of such a shield could serve as a deterrent, discouraging potential aggressors from attempting to attack the planet. Additionally, the shield could provide a layer of protection for planetary infrastructure, ensuring the safety of critical assets such as space stations, satellites, and spaceports. The benefits of a planetary shield for humanity are profound. One of the most immediate advantages would be the protection of human life and infrastructure from natural disasters like asteroid impacts. Historically, large asteroid collisions have caused mass extinctions and significant environmental changes on Earth. A planetary shield could prevent such events from occurring, preserving the planet's ecosystems and preventing loss of life on a massive scale. This would be particularly important as humanity continues to expand its presence in space, with more satellites, space stations, and potentially colonies in orbit or on other celestial bodies. Beyond protection from natural threats, a planetary shield could also play a crucial role in maintaining global stability in the face of human-made dangers. As space becomes increasingly militarized and the potential for conflicts in space grows, having a planetary defense system in place could prevent catastrophic attacks on Earth or other inhabited planets. This would reduce the risk of large-scale warfare in space, helping to maintain peace and security on a global scale. Moreover, the development and deployment of a planetary shield would drive significant advancements in technology and science. The research and engineering required to create such a shield would lead to breakthroughs in fields such as materials science, energy generation, and space-based sensors. These advancements could have wide-ranging applications, improving technologies on Earth and enabling new capabilities in space exploration. For example, the technology developed for a planetary shield could be adapted for use in protecting space habitats, lunar bases, or Martian colonies, ensuring the safety of humans living and working beyond Earth. In the future, a planetary shield could also support the terraforming efforts on other planets. By controlling and regulating the amount of solar radiation that reaches a planet's surface, the shield could help create more stable and habitable environments. This would be particularly useful in the early stages of colonization, where managing the planet's climate and protecting new settlements from space weather would be critical to the success of the mission. Number 5. Ringworlds. Ring worlds are a fascinating and ambitious concept in the realm of space megastructures, offering the potential to create vast, habitable environments far beyond what is possible on Earth. A ring world is essentially a massive ring that orbits a star, with its inner surface designed to support life. This ring would be constructed at a distance from the star where temperatures would be suitable for human habitation, creating an artificial world with an area millions of times greater than the surface of Earth. The idea, popularized by science fiction author Larry Niven, could represent the ultimate solution to the challenges of overpopulation, resource scarcity, and the quest for sustainable living spaces. A ring world would work by using centrifugal force to simulate gravity. The entire structure would rotate around its star, with the outer edge of the ring spinning at such a speed that it creates a gravitational pull on the inhabitants and objects on its inner surface. This would allow people to live, walk, and build on the ring's surface as they would on Earth, despite the structure being located in space. The ring's immense surface area would provide ample space for cities, agriculture, and natural environments, potentially accommodating billions or even trillions of people. One of the most significant benefits of a ring world is its potential to solve the issue of overpopulation. With a habitable area far greater than that of Earth, a ring world could support a vast population, providing them with space to live, work, and thrive. This would alleviate the pressures on Earth's ecosystems and resources, allowing for more sustainable development and conservation of the natural environment. The abundance of space on a ring world would also enable the creation of expansive green areas, parks, and natural reserves, enhancing the quality of life for its inhabitants. In addition to providing living space, a ring world could offer unparalleled access to resources. The structure could be designed with advanced technology to harvest solar energy directly from its star, providing virtually limitless power to its inhabitants. This energy could be used to support industries, agriculture, and the overall infrastructure of the ring world, making it largely self-sufficient. Furthermore, the ring world could be equipped with systems to capture and recycle resources, minimizing waste and ensuring the sustainability of the environment. Another intriguing aspect of a ring world is its potential for scientific research and exploration. The unique environment of a ring world, combined with its proximity to a star, would provide opportunities to study astrophysics, planetary science, and other fields in ways that are not possible on Earth. The vast size of the ring world would also enable the establishment of research centers, observatories, and laboratories dedicated to advancing human knowledge. However, the sheer amount of material needed to construct a ring world is staggering. Even if we dismantled every planet, moon, and asteroid in our solar system, it still might not provide enough matter to build such a structure. This is why a ring world is often seen as a far-future megastructure, potentially feasible only in another solar system. In the far future, a ring world could serve as a model for future space colonies, enabling humanity to establish a presence across the galaxy and ensuring the continued growth and expansion of our civilization. Number 6. Wormholes. Wormholes are a theoretical concept in physics that could revolutionize space travel by providing shortcuts through space-time, connecting distant regions of the universe in an instant. Often depicted in science fiction, wormholes, if they exist, would function like tunnels with two ends at separate points in space and time. This means that traveling through a wormhole could allow someone to traverse vast distances that would otherwise take thousands or even millions of years to cover using conventional space travel methods. The idea of wormholes originates from Einstein's theory of general relativity, which describes how massive objects warp the fabric of space-time. According to this theory, it is theoretically possible for space-time to be folded or bent in such a way that two distant points touch, creating a shortcut between them, a wormhole. In practice, a wormhole would consist of two mouths, connected by a throat, and passing through the throat would instantly transport you from one mouth to the other, regardless of the distance between them, in normal space. For wormholes to work as practical transportation devices, they would need to be stable and large enough for spacecraft to pass through. However, one of the significant challenges with wormholes is that they are predicted to be highly unstable. The immense gravitational forces involved could cause them to collapse or close before anything could pass through. Some theories suggest that exotic matter with negative energy density could be used to stabilize a wormhole, preventing it from collapsing and allowing safe passage. The potential benefits of wormholes for humanity are extraordinary. The most obvious advantage is the possibility of interstellar travel in a fraction of the time it would take using conventional methods. Instead of spending decades or centuries traveling to the nearest stars, wormholes could allow for near instantaneous travel between distant parts of the galaxy. This would open up the universe for exploration and colonization, enabling humanity to establish settlements on far-off planets, access new resources, and potentially encounter other forms of intelligent life. Wormholes could also revolutionize communication across vast distances. Currently, communicating with spacecraft or colonies on other planets involves significant time delays due to the finite speed of light. Wormholes could eliminate these delays by providing a direct link between two distant points, allowing for real-time communication across the galaxy. This would be crucial for coordinating space missions, sharing scientific data, and maintaining connections between human settlements spread across different star systems. Beyond their practical applications for travel and communication, wormholes could also provide valuable insights into the nature of the universe. Studying and understanding how wormholes work could lead to breakthroughs in fundamental physics, shedding light on the mysteries of space-time, gravity, and quantum mechanics. The existence of wormholes could also offer evidence for the theory of multiverses, suggesting that there are other universes beyond our own that could be accessed through these cosmic tunnels. The potential for wormholes to connect not just distant points in space, but also different times, adds another layer of intrigue. Theoretical models suggest that a wormhole could link different points in time, potentially enabling time travel. While this idea raises complex questions about causality and the nature of time itself, it also opens up fascinating possibilities for exploration and discovery, allowing humanity to learn more about the history of the universe or even influence future events. In the future, if wormholes were proven to exist and could be safely traversed, they could fundamentally alter the trajectory of human civilization. The ability to travel across the galaxy and beyond would expand humanity's reach, allowing us to explore and settle in regions of space that are currently beyond our grasp. This could lead to the development of a galactic civilization where humanity spreads out among the stars, thriving in multiple star systems and ensuring the long-term survival of our species. Number 7. Matrioska brains. Matrioska brains are an advanced and speculative concept in the realm of space megastructures, representing a vision of ultimate computational power. Named after the Russian nesting dolls which stack within one another, a Matrioska brain would consist of a series of concentric Dyson spheres, each one encompassing the previous layer, built around a star. These layers would be made of advanced solar collectors and computational nodes, allowing the entire structure to harness the star's energy and convert it into an almost incomprehensible amount of computing power. The core idea of a Matrioska brain is to maximize the use of a star's energy output by capturing it at multiple levels. The innermost shell would be a traditional Dyson sphere, which directly absorbs energy from the star. Surrounding this inner sphere, additional layers would be constructed, each absorbing the energy radiated by the layer beneath it. This process would continue outward, with each successive shell capturing and utilizing energy that would otherwise be lost to space. The outermost layer would radiate minimal heat, making the Matrioska brain an incredibly efficient system for energy utilization. The computing power of a Matrioska brain would be virtually limitless. Each layer would be packed with computational nodes that operate at incredibly high speeds, processing information and running simulations on a scale far beyond anything currently imaginable. This immense computational capacity could be used for a wide range of applications, from running detailed simulations of the universe to solving complex problems in science, mathematics, and technology. It could even support the creation of highly sophisticated artificial intelligence systems, enabling the development of entities with intelligence surpassing all humans who have ever lived. One of the most profound benefits of a Matrioska brain would be its potential to advance scientific knowledge and understanding. With its vast computational resources, a Matrioska brain could simulate entire ecosystems, weather patterns, or even the universe itself. It could help humanity explore the deepest mysteries of physics, such as the nature of dark matter, the behavior of quantum particles, or the origins of the universe. By running simulations of different scenarios, it could predict the outcomes of various cosmic events, from the formation of galaxies to the evolution of stars. Additionally, a Matrioska brain could revolutionize the field of artificial intelligence. With its immense processing power, it could support the creation of AI entities with unparalleled cognitive abilities. These AI systems could assist in solving some of humanity's greatest challenges, from climate change to disease eradication, by processing and analyzing vast amounts of data more efficiently than any human could. The Matrioska brain could also simulate entire societies or virtual worlds, allowing for the exploration of different social, economic, and technological systems in a controlled environment. Furthermore, the potential for digital immortality could be realized within a Matrioska brain. Humans could upload their consciousness into the structure, effectively achieving a form of digital immortality, where their minds continue to exist and evolve within the virtual environment created by the Matrioska brain. This could allow individuals to live out multiple lifetimes, exploring different experiences, worlds, and realities in a safe and controlled environment. This concept of mind uploading could fundamentally change the nature of human existence, offering new possibilities for personal growth, learning, and exploration. Number 8. Space elevators. Space elevators are one of the most intriguing and potentially transformative concepts in the field of space exploration. A space elevator would be a giant structure extending from Earth's surface to a point far beyond geostationary orbit, around 22,000 miles above the equator. This structure would enable the transportation of materials, equipment, and even people into space without the need for rockets, drastically reducing the cost and environmental impact of accessing space. The idea, first proposed in the late 19th century, has gained renewed interest as materials science and engineering have advanced, making it a more plausible endeavor in the future. The core of a space elevator would be its tether, an immensely strong and lightweight material that could stretch from Earth's surface to space. The most promising candidate for this tether is carbon nanotubes or graphene, materials that are incredibly strong yet lightweight enough to make the concept feasible. The tether would be anchored to a platform at the equator and extend upward to a counterweight in space, beyond geostationary orbit. This counterweight would keep the tether taut through the centrifugal force generated by Earth's rotation, effectively balancing the entire structure. To travel up and down the space elevator, specially designed vehicles called climbers would be used. These climbers would be electrically powered, possibly through solar energy or beamed power from the ground, and would ascend or descend along the tether. Unlike rockets, which require vast amounts of fuel and generate significant pollution, these climbers would operate more like elevators in a skyscraper, providing a smooth, continuous journey into space. The benefits of space elevators for humanity could be profound. One of the most significant advantages is the potential to dramatically reduce the cost of sending materials and people into space. Currently, launching payloads into orbit using rockets is extremely expensive, often costing thousands of dollars per kilogram. A space elevator could reduce these costs by a factor of 100 or more, making space more accessible for a wide range of activities, from scientific research to commercial ventures. This reduction in cost could spur a new era of space exploration and development, enabling the construction of space habitats, factories, and even space-based solar power stations that could provide clean energy for Earth. In addition to lowering costs, space elevators could also reduce the environmental impact of space travel. Traditional rocket launches generate significant pollution, both in the atmosphere and on the ground, where rocket fuel and other chemicals can cause environmental damage. By using electric-powered climbers, space elevators would produce little to no emissions, making them a far more sustainable option for accessing space. This would be particularly important as the demand for space travel increases, helping to ensure that humanity's expansion into space does not come at the expense of Earth's environment. Another important benefit of space elevators is their potential to enable large-scale construction projects in space. With the ability to transport massive amounts of materials to orbit at a low cost, space elevators could facilitate the building of space habitats, research stations, and even spacecraft. These structures could be assembled in space, where there are no gravitational constraints, allowing for the creation of megastructures that would be impossible to build on Earth. This capability could accelerate the colonization of the Moon, Mars, and other celestial bodies, as well as the development of space-based industries that could drive economic growth and innovation. Number 9. Orbital mining stations. Orbital mining stations represent a transformative concept in space exploration and resource acquisition, offering humanity the potential to access the vast wealth of materials available in asteroids, moons, and other celestial bodies. These stations would serve as hubs for mining operations in space, extracting valuable minerals, metals, and other resources directly from these celestial bodies and processing them in orbit. The idea of orbital mining is rooted in the understanding that many of the materials that are rare or difficult to obtain on Earth exist in abundance in space, particularly in asteroids, which are rich in elements like platinum, gold, nickel, and water. An orbital mining station would work by positioning itself near an asteroid or another resource-rich body, such as a moon or a small planet. The station would be equipped with advanced robotics, autonomous mining equipment, and processing facilities designed to operate in the harsh conditions of space. These machines would mine the target body, extracting raw materials and transporting them to the station for processing. Once processed, these materials could be used directly in space, for example, in the construction of space habitats, satellites, or other megastructures, or transported back to Earth for use in various industries. One of the most significant benefits of orbital mining stations is their potential to revolutionize resource availability on Earth. As our planet's population grows and the demand for raw materials increases, the pressure on Earth's finite resources becomes more intense. By tapping into the virtually limitless supply of materials in space, orbital mining stations could alleviate this pressure, providing a new source of critical resources like rare metals and water. This could reduce the environmental impact of mining on Earth, preserving
Вот мне нам танцы, мои слова я творю. пути к звездам. On the grind, мой девиз, мой путь неустанный. On the grind, я качаю биты, мои рифмы снаряды летят сквозь лимиты. Я творец своей судьбы, я во власти этих слов. On the grind, я меняю мир, ломая устои. On the grind, я меняю мир, ломая устои. Не боюсь преград, я иду к своей цели, как танк, невзирая на трудности. Это лишь ступени вверх. On the grind, я взлетаю, как птица с ветра вперед. Я художник своей жизни, пишу свой сюжет. Каждый день это новый виток, новых звезд. Не боюсь ошибок, я учусь на лету. On the grind, я расту, становлюсь сильнее. On the grind, я качаю биты, мои рифмы снаряды летят сквозь лимиты. Я творец своей судьбы, я во власти этих слов. On the grind, я меняю мир, ломая устои. On the grind, я качаю биты, мои рифмы снаряды летят сквозь лимиты. Я творец своей судьбы, я во власти этих слов. On the grind, я меняю мир, ломая устои. On the grind, я веду до конца. Моя жизнь это пламя, моя душа песня.
Systems and reducing the degradation of natural landscapes. In addition to supplying materials for Earth, orbital mining stations could play a crucial role in the development of space infrastructure. The construction of space habitats, solar power stations, and other megastructures requires vast amounts of material, much of which would be prohibitively expensive to launch from Earth due to the high cost of space transportation. By sourcing these materials directly from space, orbital mining stations could significantly reduce the cost and complexity of building in space, making large-scale projects more feasible. This could accelerate the development of space colonies, research stations, and other facilities that support a growing human presence in space. Moreover, orbital mining stations could contribute to the sustainability and longevity of space missions. Water, for example, is a critical resource for life support systems, as well as for producing rocket fuel through electrolysis. By extracting water from asteroids or moons and processing it in orbit, these stations could provide a reliable and cost-effective supply of fuel and life support resources for missions to the Moon, Mars, and beyond. This would enable longer and more ambitious missions, reducing the need for resupply missions from Earth and increasing the autonomy of spacecraft and space habitats. The economic potential of orbital mining stations is also immense. The value of the materials available in just a single asteroid can be staggering. Some estimates suggest that the resources in certain asteroids could be worth trillions of dollars. By establishing a network of orbital mining stations, humanity could tap into this wealth, driving economic growth and creating new industries centered around space resource extraction and processing. This could lead to the development of new markets, job creation, and technological innovation, further integrating space into the global economy. In the future, orbital mining stations could also support interplanetary trade and the creation of a space-based economy. As humanity expands its presence in space, the need for materials and goods in orbit will increase. Orbital mining stations could serve as nodes in a supply chain that stretches across the solar system, providing the raw materials needed for construction, manufacturing, and life support in space. This could enable the growth of space colonies and the establishment of trade routes between Earth, the Moon, Mars, and other locations, fostering a vibrant and interconnected space economy. Number 10. Penrose spheres around black holes. Penrose spheres are an ambitious and speculative concept in the realm of space megastructures, inspired by the theoretical ideas of physicist Roger Penrose. These structures are designed to harness the immense energy found in the vicinity of a rotating black hole. Unlike traditional energy sources, which rely on chemical, nuclear, or solar power, Penrose spheres would tap into one of the most powerful and mysterious forces in the universe, the rotational energy of a black hole. The basic idea behind a Penrose sphere is to create a massive spherical structure that encircles a rotating black hole, known as a Kerr black hole. The black hole's rotation causes the surrounding space-time to twist in a phenomenon known as frame dragging. This effect creates an ergosphere, a region just outside the event horizon, where objects can potentially gain energy by following specific trajectories. A Penrose sphere would be designed to capture this energy by carefully manipulating objects or particles within the ergosphere. extracting energy from the black hole's rotation without falling into it. In practical terms, the Penrose process involves sending material into the ergosphere on a precise trajectory. Once inside this region, the material would split into two parts. One part falls into the black hole, while the other escapes with more energy than it originally had. The escaping material, now energized, could be collected and converted into usable power. By repeating this process continuously, a Penrose sphere could theoretically extract vast amounts of energy from the black hole, effectively using it as a cosmic power plant. The benefits of a Penrose sphere for humanity could be profound. First and foremost, it offers a nearly limitless source of energy. The rotational energy of a black hole is immense, and a Penrose sphere could harness this energy for countless applications. This could provide power not only for space-based infrastructure, such as space stations, habitats, and spacecraft, but also for advanced technologies that require enormous amounts of energy, such as large-scale simulations, artificial intelligence, and even interstellar propulsion systems. In addition to energy generation, Penrose spheres could play a critical role in deep space exploration and colonization. The ability to harness the energy of a black hole would enable long-term sustainable human presence in regions of space far from the sun or other stars. This would allow humanity to establish colonies and research stations near black holes, exploring some of the most extreme and intriguing environments in the universe. The proximity to a black hole would also provide unique opportunities for scientific research, potentially leading to breakthroughs in our understanding of gravity, quantum mechanics, and the nature of spacetime. Another intriguing possibility is the use of Penrose spheres in the development of advanced propulsion systems. The energy extracted from a black hole could be used to power spacecraft capable of reaching incredible speeds, potentially even allowing for faster-than-light travel through theoretical concepts such as warp drives or wormholes. This could revolutionize space travel, making interstellar journeys feasible and opening up the entire galaxy for exploration and colonization. The construction of a Penrose sphere would be an unprecedented engineering challenge, requiring materials and technologies that are currently beyond our reach. However, the pursuit of this concept could drive significant advancements in fields such as materials science, energy storage, and space construction. Number 11. Interplanetary relay networks. An interplanetary relay network is a visionary concept designed to enhance communication across the vast distances of our solar system, serving as the backbone for interplanetary exploration, colonization, and commerce. As humanity sets its sights on establishing a presence on other planets and moons, the need for reliable, high-speed communication between Earth and these distant outposts becomes increasingly critical. An interplanetary relay network would address this need by creating a network of satellites, space stations, and ground-based relays that facilitate seamless communication across millions or even billions of kilometers. The concept of an interplanetary relay network revolves around deploying a series of communication satellites in strategic orbits around planets, moons, and other key locations in the solar system. These satellites would be equipped with advanced communication technologies, such as high-frequency radio waves, lasers, or even quantum communication systems, to transmit data at the highest possible speeds. The network would be designed to ensure that signals can be transmitted continuously, avoiding the delays and interruptions that currently occur when spacecraft or planets move out of alignment with Earth. Each relay station in the network would act as a node, receiving, amplifying, and forwarding signals from one location to another. For example, a signal sent from a Mars colony could be transmitted to a satellite orbiting Mars, which would then relay the signal to another satellite positioned between Mars and Earth, and finally to a receiving station on Earth. This relay system would allow data to travel across the solar system with minimal delay, enabling real-time communication and data exchange between Earth and distant space missions. The benefits of an interplanetary relay network for humanity are numerous and far-reaching. First and foremost, it would vastly improve the safety and effectiveness of space exploration missions. Currently, communication delays between Earth and Mars can range from several minutes to over 20 minutes, depending on the planet's relative positions. These delays can hinder mission control's ability to respond to emergencies or guide rovers and spacecraft in real time. An interplanetary relay network would reduce these delays, enabling faster decision-making and more precise control over missions, thereby enhancing the safety and success of space exploration. In addition to improving mission control, an interplanetary relay network would be essential for supporting human settlements on other planets and moons. As colonies on Mars, the Moon, and other celestial bodies become a reality, the need for reliable communication will be paramount. Colonists will need to communicate with Earth for everything from coordinating supply shipments to staying in touch with loved ones. The network would ensure that these communications are as seamless as possible, helping to maintain a strong connection between Earth and its off-world colonies. The network would also be crucial for scientific research and data collection. As space probes, telescopes, and landers explore distant planets, moons, and asteroids, they generate vast amounts of data that must be transmitted back to Earth for analysis. An interplanetary relay network would provide the bandwidth and reliability needed to transmit high volumes of data quickly and accurately. This would accelerate scientific discoveries, enabling researchers to analyze new information in near real time and make groundbreaking advancements in our understanding of the solar system. Moreover, an interplanetary relay network could pave the way for the development of an interplanetary internet, connecting not just Earth, but also multiple planets, moons, and space stations in a vast digital network. This would allow for the creation of new forms of communication, commerce, and collaboration across the solar system. For example, companies could establish interplanetary business operations, researchers could collaborate on projects in real time from different planets, and individuals could access entertainment, education, and social networks from anywhere in the solar system. In the future, the interplanetary relay network could also play a critical role in supporting interstellar exploration. As humanity looks beyond our solar system to explore nearby star systems, the relay network could be expanded to include deep space communication stations, enabling long-distance communication with interstellar probes, and potentially even with other civilizations. Number 12. Stellar engines. Stellar engines are a theoretical concept for gigantic space megastructures designed to move entire stars and their surrounding solar systems. The idea is both awe-inspiring and incredibly ambitious, as it envisions humanity gaining control over the movement of stars, effectively steering entire solar systems through the galaxy. While this might sound like science fiction, the concept is rooted in the laws of physics and represents a fascinating exploration of what could be possible in the distant future. A stellar engine would work by harnessing the energy output of a star to generate thrust, gradually pushing the star and everything in its orbit in a specific direction. One of the most well-known designs for a stellar engine is the Shkadov thruster, named after the Russian physicist Leonid Shkadov, who proposed it. This design involves constructing a massive reflective structure, such as a giant mirror or a Dyson sphere-like surface, that partially surrounds the star. The structure would reflect a portion of the star's light back toward it, creating a pressure imbalance that would exert a gentle but continuous thrust on the star. Over time, this thrust would accumulate, causing the star to move slowly through space. Another more advanced design is the Kaplan thruster, which combines the principles of a Dyson sphere and a fusion-based propulsion system. In this concept, a large structure would capture solar energy and use it to power a fusion engine that expels high-velocity plasma or other propellant. This expelled material would push against the star, creating a reaction force that moves the entire system. The Kaplan thruster could potentially generate more significant thrust than the Shkadov thruster, making it a more powerful and efficient method for moving stars. Stellar engines could enable humanity to explore and colonize new regions of the galaxy. By moving our solar system closer to other stars, we could make interstellar travel more feasible, reducing the distances between solar systems and opening up new opportunities for exploration and settlement. This could lead to the establishment of human colonies on exoplanets or in other star systems, spreading life across the galaxy and creating a network of interconnected civilizations. Stellar engines could also play a role in the long-term management of the galaxy's resources. As humanity expands and consumes more energy, access to new sources of energy will become increasingly important. By moving our solar system to regions of the galaxy rich in resources, such as areas with high concentrations of dark matter or other valuable materials, we could ensure a steady supply of energy and resources for future generations. This would enable the continued growth and development of human civilization on a galactic scale. Number 13. Space-based particle accelerators. Space-based particle accelerators represent an extraordinary leap in scientific ambition, taking the concept of particle physics research to new cosmic heights. These colossal machines would be designed to accelerate subatomic particles to nearly the speed of light, enabling experiments that could probe the deepest mysteries of the universe. By constructing these accelerators in the vacuum of space, far beyond the limitations of Earth-bound facilities, scientists could achieve energies and conditions unattainable on our planet, leading to groundbreaking discoveries that could reshape our understanding of physics and the cosmos. A space-based particle accelerator would operate on the same basic principles as those on Earth, such as the Large Hadron Collider at CERN, but on an incomparably larger scale. Particles, such as protons or electrons, would be injected into the accelerator and guided along a circular or linear path by powerful magnetic fields. As the particles travel through the accelerator, they would be subjected to electromagnetic fields that accelerate them to incredible speeds, approaching the speed of light. These high-energy particles would then be collided with each other or with stationary targets, allowing scientists to observe the resulting interactions and study the fundamental forces and particles that make up the universe. Building a space-based particle accelerator offers several distinct advantages over Earth-based facilities. The most significant is the absence of atmospheric and gravitational constraints. In the vacuum of space, particles can be accelerated over much longer distances without losing energy to air resistance or being affected by Earth's gravity. This allows for the construction of much larger accelerators, potentially spanning hundreds or even thousands of kilometers. The larger the accelerator, the higher the energy levels that can be achieved, enabling the study of phenomena that require extreme conditions, such as those present in the early moments of the universe. Another advantage of constructing particle accelerators in space is the reduced risk of radiation exposure to humans and the environment. High-energy particle collisions can produce intense radiation, including harmful gamma rays and other forms of ionizing radiation. By placing these accelerators in space, far from Earth, the potential dangers associated with these experiments would be minimized, allowing scientists to conduct more powerful and ambitious experiments without risking public safety. One of the most profound benefits of a space-based particle accelerator would be its potential to answer fundamental questions about the nature of the universe. For instance, these accelerators could recreate conditions similar to those just after the Big Bang, allowing scientists to study the formation of matter, the behavior of dark matter, and the unification of fundamental forces. By achieving higher energies than those possible on Earth, these accelerators could explore new realms of physics, potentially leading to the discovery of unknown particles or forces, and deepening our understanding of the fabric of reality. In addition to advancing our knowledge of fundamental physics, space-based particle accelerators could have practical applications that benefit humanity. For example, they could be used to test and develop new materials and technologies that can withstand extreme conditions, such as those encountered in space exploration or nuclear fusion reactors. These advancements could lead to more durable spacecraft, improved energy production methods, and new industrial processes that enhance sustainability and efficiency. In the future, a network of space-based particle accelerators could be established across the solar system, providing a platform for continuous and collaborative research on an unprecedented scale. Such a network could bring together scientists from around the world, fostering international cooperation and shared knowledge. The data generated by these accelerators could revolutionize our understanding of the universe, leading to new theories and discoveries that could reshape the course of human history. Number 14. Universal constructors. Universal constructors in space represent one of the most ambitious concepts in the field of space exploration and megastructure construction. These theoretical machines, sometimes referred to as von Neumann machines, after the mathematician who first conceived the idea, are designed to be fully autonomous, self-replicating robots capable of building virtually anything, including themselves. Operating in space, these universal constructors could revolutionize humanity's ability to construct large-scale structures and harness resources from other planets, asteroids, and beyond. A universal constructor would work by first using raw materials available in space, such as the minerals found in asteroids, moons, or even planetary surfaces, to create components and machinery. These materials would be mined, refined, and processed by the constructor itself, which would then use them to fabricate new units or to assemble complex structures. One of the most critical aspects of these machines is their ability to replicate themselves, meaning that a single universal constructor could build copies of itself, exponentially increasing the number of constructors working in space. This self-replication process could turn a small initial investment into a vast fleet of machines capable of undertaking massive construction projects across the solar system. The potential benefits of universal constructors for humanity are immense. One of the most significant advantages would be their ability to construct large-scale space infrastructure without the need for constant resupply from Earth. This could include building space habitats, solar power stations, or even planetary defense systems. By using local resources and being fully autonomous, universal constructors would reduce the need for costly and risky launches from Earth, making space exploration and development more sustainable and affordable. Another profound benefit of universal constructors would be their role in asteroid mining. The vast resources locked within asteroids, such as rare metals and water, could be harnessed by these machines to support both Earth's economy and future space colonization efforts. The extracted materials could be used to build space habitats, fuel stations, or other essential infrastructure, potentially leading to a self-sufficient space economy. Moreover, by mining asteroids and other celestial bodies, humanity could reduce the environmental impact of mining on Earth, preserving our planet's ecosystems while still meeting the growing demand for resources. Universal constructors could also play a crucial role in the construction of space megastructures, such as Dyson spheres or O'Neill cylinders. These colossal structures, designed to harness massive amounts of energy or provide living space for millions of people, would require the assembly of materials on an unprecedented scale. Universal constructors, with their ability to replicate and work autonomously, would be the perfect solution to the logistical challenges of building such megastructures. They could operate in the vacuum of space, assembling components piece by piece over long periods, eventually creating structures that would be impossible to build using traditional methods. In the future, as technology advances, universal constructors could even be used to terraform planets or moons, making them suitable for human habitation. By constructing vast networks of infrastructure and altering the environment of these celestial bodies, these machines could lay the groundwork for new human colonies, extending humanity's reach into the cosmos. This capability would be essential for long-term survival and expansion, allowing humans to establish a presence on multiple planets and reduce the risk of extinction from global catastrophes on Earth. Moreover, the development and deployment of universal constructors could lead to a new era of exploration and discovery. With a fleet of self-replicating machines, humanity could explore the farthest reaches of the solar system and beyond, building research stations, telescopes, and communication networks to study the universe in greater detail. Number 15. Dyson spheres. Dyson spheres are one of the most ambitious and iconic concepts in the realm of space megastructures, representing a theoretical structure designed to harness the total energy output of a star. Named after the physicist Freeman Dyson, who popularized the idea in the 1960s, a Dyson sphere would be an enormous shell surrounding a star, capturing and converting its radiant energy into usable power. The idea stems from the notion that as a civilization grows and its energy needs increase, it would eventually seek to capture the full energy potential of its star, propelling it to a new level of technological advancement. Since Dyson spheres are quite similar to Dyson swarms, which were discussed earlier, I won't go into detail about their energy benefits. One of the most compelling aspects of a Dyson sphere is its potential to serve as a habitat for an enormous population. The sheer scale of the structure means that it could provide living space for trillions of people, far exceeding the capacity of Earth. Each habitat within the Dyson swarm could be designed with artificial gravity, climate control, and ecosystems tailored to human needs, offering a comfortable and Earth-like environment in space. These habitats could be connected through a network of transportation systems, communication links, and energy grids, creating a cohesive and interconnected civilization spread across millions of individual units. Given the potential material limitations within our solar system, constructing a Dyson sphere might be more feasible in another solar system in the distant future. Additionally, if alien civilizations have constructed Dyson spheres, these structures could serve as markers to identify and locate those civilizations. Number 16. Starlifters. Starlifters are an advanced and speculative concept in the field of space megastructures, representing one of the most ambitious ideas for harnessing the vast energy and material resources of stars. The idea behind a starlifter is to construct a massive structure or system capable of extracting matter directly from a star, such as our Sun, to utilize its elements for various purposes. This process could enable humanity to access enormous quantities of raw materials, potentially transforming our ability to build large-scale space structures and sustain long-term space exploration. A starlifter would work by creating a mechanism that could reach into the outer layers of a star and extract its material without disrupting the star's stability. This could be achieved using advanced technologies like powerful magnetic fields, solar sails, or even a series of interconnected tethers designed to pull stellar material away from the star's surface. Once extracted, the matter could be processed and separated into its constituent elements, such as hydrogen, helium, and heavier metals, which could then be used for various applications. One of the primary uses of the material harvested by a starlifter would be in the construction of other space megastructures, such as Dyson spheres, space habitats, or even more starlifters. Stars contain vast amounts of hydrogen, which could be used as fuel for fusion reactors, providing a nearly limitless energy supply for human civilization. The ability to extract and utilize these elements would vastly expand our resource base, reducing our dependence on the limited resources available on Earth and within our solar system's asteroids and planets. Beyond resource extraction, starlifters could also play a crucial role in managing the long-term future of stars. As stars age, they go through various stages of evolution, eventually exhausting their nuclear fuel and potentially undergoing catastrophic changes, such as expanding into red giants or collapsing into supernovae. For example, starlifters could be employed to extend the lifespan of our Sun, delaying its predicted expansion into a red giant about 5 billion years from now. This would enable Earth to support life for much longer than current scientific predictions suggest. Number 17. Stanford Torus. The Stanford Torus is a concept for a space habitat that could provide a permanent living environment for humans in space. Originally proposed in the 1970s by a team of researchers at Stanford University as part of a NASA study, the Stanford Torus is a giant, donut-shaped structure designed to orbit Earth or another celestial body. This space megastructure would rotate to create artificial gravity, allowing humans to live and work in a comfortable, Earth-like environment while orbiting in space. This space megastructure is also featured in the movie Elysium, where it serves as a luxurious haven for the wealthy. The Stanford Torus would work by rotating around its central axis, with the rotational speed carefully calculated to create centrifugal force equivalent to Earth's gravity. This force would push everything inside the torus outward, mimicking the experience of gravity and enabling people to walk, move, and build as they would on Earth. The Stanford Torus would be notably smaller than an O'Neill cylinder and have a diameter of about 1 mile. It would rotate at approximately 1 revolution per minute to generate the desired level of gravity. The interior of the torus would be lined with habitats, parks, agricultural zones, and other facilities necessary for sustaining human life. Since the Stanford Torus is quite similar to O'Neill cylinders, I won't delve further into its interior and overall structure. For more details about those aspects, please refer to the section on O'Neill cylinders. The Stanford Torus could play a key role in the colonization of other celestial bodies, such as the Moon or Mars. By providing a nearby base of operations, the Torus could support missions to the surface of these bodies, serving as a staging ground for exploration, resource extraction, and eventual settlement. The Torus itself could be expanded or replicated, creating a network of interconnected habitats that support a growing human presence in space. In the future, the Stanford Torus could also serve as a hub for space tourism, providing a unique destination for visitors seeking to experience life in space. As space travel becomes more accessible, the Torus could offer a comfortable and safe environment for tourists, allowing them to enjoy the beauty of space while participating in activities such as zero-gravity sports, stargazing, and virtual reality experiences. This could open up new avenues for economic growth and help to democratize access to space, making it a more integral part of human life. Number 18. Alderson Disks. Alderson disks are one of the most ambitious and speculative concepts in the realm of space megastructures, offering an entirely new vision of how humanity could inhabit and utilize space. Named after the science fiction author Dan Alderson, who first proposed the idea, an Alderson disk would be a massive flat structure surrounding a star, providing a habitable surface area that could dwarf that of any planet. An Alderson disk would be considerably larger than a ring world. An Alderson disk would be so large that its radius could extend from the orbit of Mercury to beyond the orbit of Mars, creating an immense, continuous landmass with the potential to support trillions of people. The fundamental idea behind an Alderson disk is to create a habitable environment by constructing a colossal disc-shaped platform around a star. The star would sit at the center of the disk, providing energy and light to the vast surface area of the structure. The disk itself would need to be incredibly thick to generate enough gravitational pull to keep its atmosphere and inhabitants securely in place. This gravity would be similar to that on Earth, allowing for normal living conditions. The outer edge of the disk could be several astronomical units away from the star, making the habitable zone of the disk incredibly vast. One of the most interesting aspects of an Alderson disk is the potential for controlled climates and ecosystems. Given the sheer size of the disk, it could be designed with different regions having varied climates, from tropical zones near the star to temperate regions farther out. Artificial oceans, rivers, and mountains could be constructed across the disk, creating a diverse range of environments for agriculture, habitation, and natural ecosystems. The disk's immense surface area would offer virtually unlimited space for cities, farmlands, and nature reserves, allowing humanity to expand and thrive without the environmental constraints we face on Earth. In terms of energy, an Alderson disk would have almost limitless potential. Solar energy collectors could be spread across the disk's surface to harness the star's power, providing an inexhaustible energy supply for the inhabitants. This energy could be used not only for daily needs, but also for large-scale industrial processes, space travel, and other advanced technologies. With such abundant energy resources, the disk could become a hub for scientific research, manufacturing, and technological innovation, driving human progress to new heights. Another significant benefit of an Alderson disk is its potential to serve as a stable platform for deep space exploration. With such a large and resource-rich structure, the disk could support the construction and launch of interstellar spacecraft, providing a base for humanity's expansion into the wider galaxy. The disk's proximity to its star also means that it could be an ideal location for observing and studying the star itself, as well as for monitoring and managing space traffic in the surrounding system. Additionally, the disk could act as a shield, protecting its inhabitants from space debris and cosmic radiation, thanks to its thick, robust construction. Number 19. Planetary engines. Planetary engines are an extraordinary concept within the realm of space megastructures, offering a theoretical means of moving entire planets. The idea behind planetary engines is to build colossal machines that can generate enough thrust to alter a planet's orbit, direction, or even its position within the solar system. For information on potential designs for planetary engines, please refer to the earlier section on stellar engines. The potential benefits of planetary engines for humanity are profound, particularly when considering the long-term survival and adaptability of our civilization. One of the most significant advantages would be the ability to protect Earth or other inhabited planets from cosmic threats. For instance, in the distant future, the Sun is predicted to eventually exhaust its nuclear fuel and expand into a red giant, potentially engulfing the inner planets, including Earth. By using a planetary engine, humanity could slowly move Earth away from the expanding Sun, preserving the planet's habitability and ensuring the survival of life. Planetary engines could also be used to prevent catastrophic asteroid or comet impacts. If a large enough object were detected on a collision course with Earth, a planetary engine could be activated to gently alter Earth's orbit, moving it out of the path of the incoming object. This would provide a powerful tool for planetary defense, reducing the risk of extinction-level events. Moreover, planetary engines could play a role in terraforming and climate control. If a planet's orbit or axial tilt is adjusted, it could change the distribution of sunlight and heat across the planet's surface, potentially stabilizing its climate or making it more suitable for life. For example, a planetary engine could be used to slightly alter Earth's tilt or orbit, helping to mitigate the effects of climate change, or to make other planets such as Mars more habitable. And we could potentially move planets like Mars and Venus to more habitable regions of the solar system. However, altering planetary locations carries significant risks, and the effects of changing the gravitational balance in the solar system would need to be carefully evaluated. Number 20. Atmosphere harvesters. Atmosphere harvesters are an innovative concept that could play a crucial role in humanity's future exploration and colonization of other planets. These megastructures would be designed to extract and process gases from the atmospheres of planets, moons, or even gas giants, converting them into usable resources such as oxygen, water, and fuel. By harnessing the abundant atmospheric resources found on other celestial bodies, atmosphere harvesters could support sustained human presence in space, reduce the need for resupply missions from Earth, and open up new possibilities for space exploration and industry. An atmosphere harvester would work by first capturing atmospheric gases using large-scale intake systems, which might resemble massive scoops or funnels. These structures would be positioned in or above the atmosphere of a target planet or moon, where they could continuously collect gases as they move through the atmosphere. Once the gases are captured, they would be directed into processing units within the harvester. Here, the gases would be separated, purified, and converted into useful forms. For example, carbon dioxide could be split into oxygen and carbon, while hydrogen could be extracted from water vapor. The resulting products could then be stored for later use or transported to other locations. One of the most promising applications of atmosphere harvesters is on Mars, where the atmosphere is composed primarily of carbon dioxide. An atmosphere harvester on Mars could produce oxygen for human consumption and rocket fuel for return missions or travel to other destinations. This capability would be a game changer for Mars exploration and colonization, as it would significantly reduce the reliance on supplies sent from Earth. Instead, astronauts could produce much of what they need directly from the Martian environment, making long-term missions more sustainable and cost-effective. In addition to supporting human life, atmosphere harvesters could be used to produce water, which is essential for both drinking and agriculture. By extracting water vapor from the atmosphere or processing hydrogen and oxygen, these structures could create a reliable water supply for space colonies. This would enable the cultivation of crops and the development of self-sustaining ecosystems on other planets, further reducing the need for Earth-based resources and increasing the viability of space colonization. Another potential application of atmosphere harvesters is on gas giants like Jupiter or Saturn. These planets have thick atmospheres rich in hydrogen and helium, which could be harvested and used as fuel for fusion reactors or advanced propulsion systems. By tapping into these vast atmospheric reserves, humanity could gain access to nearly limitless energy resources, driving technological advancements and enabling more ambitious space missions. The ability to harvest fuel directly from the atmospheres of gas giants could also make deep space exploration more feasible, allowing spacecraft to refuel as they travel through the solar system. Atmosphere harvesters could also contribute to terraforming efforts, where the goal is to alter the environment of a planet or moon to make it more habitable for humans. By selectively extracting or adding specific gases to an atmosphere, these structures could help regulate temperature, pressure, and composition, gradually transforming the environment to better support life. For instance, on Mars, atmosphere harvesters could be used to increase the level of greenhouse gases, warming the planet and thickening its atmosphere, which could eventually make it more Earth-like. These harvesters would likely be highly automated as well, using advanced AI and robotics to manage the complex processes of gas extraction and conversion. The technologies developed for atmosphere harvesters could have applications on Earth as well, such as in environmental monitoring, air purification, and industrial gas production. Thanks for watching. Make sure to watch this next